Hi guys, today we can have the discussion about one of the most important topics of chapter 3, pair of linear equations in two variables. It's nothing but equations reducible to a pair of linear equation in two variables. We shall consider some pairs of equations in two variables which are not linear. But however, we have to find out the solution for the system. So the key point involved in solving such pairs of equation is to first reduce these to linear form by some suitable rearrangement, and then solve by any one of the non-algebraic methods. We are familiar with the methods like substitution, elimination or cross multiplication. Let us consider one example to explore this concept more. Solve the following pair of equations by reducing them to a pair of linear equation. Question number 1. 10 upon x plus y plus 2 upon x minus y equals 4, and the second one 15 upon x plus y minus 5 upon x minus y equals negative 2. So, which are the steps involved? The very first step, reduce the equations to linear form. In order to reduce, we are giving a substitution over here. Let 1 upon x plus y equals p and 1 upon x minus y equals q. By substituting the values of p and q in the given equations, we get 10p plus 2q equals 4 and 15p minus 5q equals negative 2. Step number 2. Express the linear equation so obtained in the standard form. So, can you tell me what is the standard form for the linear equation in two variables? Ax plus by plus c equal to 0, where a, b, c are the constants. It can be any real number, and a and b not equal to 0. 10p plus 2q minus 4 equals 0. Let it be the first one. And 15p minus 5q plus 2 equal to 0. Now we got in standard form. We can apply, that is the step number 3, any one of the algebraic methods. It's up to you which method is comfortable for you. You can apply substitution, elimination or cross multiplication. For the time being, we are going to discuss the elimination method. So let's have a look which are the rules behind elimination method. Rule number 1, make the coefficients of one of the variables equal. For that, we are multiplying equation 1 by 5 and the equation number 2 by 2. So we get 50p plus 10q minus 20 equals 0. That is, we are multiplying the very first one by 5. If you are multiplying, means throughout we have to multiply. That means each and every term in the equation has to be multiplied by 5. So we are getting a new equation number 3. Let's move on to the next one. The second equation we are multiplying by 2. So here it comes, 30p minus 10q plus 4 equals 0. Let it be equation number 4. Have a look for the variable q. The coefficients are same. Now here it comes rule number 2. Easily we can eliminate the variable q from the list. For that, what we are doing, please check the sign of the term plus 10q and minus 10q. In order to eliminate definite, I had to add both the equation 3 and 4. Let's proceed. 50p plus 10q minus 20 equal to 0. We are going to add with 30p minus 10q plus 4 equals 0. By adding both the equations, we are getting 50 plus 30 means it's nothing but 80. 80p and plus 10q minus 10q. If you are adding both, different sign, definitely we are getting the answer 0. So no need to express that one. Just ignore it. And go for the next term, minus 20 plus 4. One negative, one positive, and we are well versed in that one. If it comes to different sign, definitely go for the subtraction. The difference between the numbers 20 and 4, it's 16, and sign of the bigger number minus. So it comes minus 16 equals 0. Now it comes the role of the transposition. we are transposing minus 16 to the right side. If you are transposing, definitely the sign changes and the negative will turn as positive. So we are getting 80p equals 16. The next step, we need the value for p. So p equals 16 on the right. 16 has to be divided by 80. Again the same rule transposition for you, which is equal to, now I can say that 80 is common in between both the numerator and denominator. We can make it as the simplest form, 2 by 10. Further go for the next one. Both are even numbers. Of course it is divisible by 2. We are getting the simplest form, 1 by 5. So here it comes the value of p as 1 by 5. Rule number 3. Now we need the value for q. What shall we do? Substitute the value of p in any one of the equation. So here I am taking equation number 4. 30p minus 10q plus 4 equal to 0. So I am just transposing q to the right hand side. 30p plus 4 equals 10q. The same thing, the transposition we are doing here. The sign changes. So 10q equals, here I am replacing p by 1 by 5 as we got the value of p as 1 by 5. 30 multiplied by 1 by 5 plus 4. What is 30 by 5? It is 6. 6 plus 4 we are getting 10, but still we haven't got the value for q. What is q? 10q equals 10 means q, of course it is 10 divided by 10, we are getting 1. Still we are not getting the final answer because our target is to get the value for x and y. So here it comes step number 4. Substitute the value of p and q in 1 upon x plus y and 1 upon x minus y respectively. We get 1 upon x plus y equals 1 by 5 implies x plus y equal to 5. The same like 1 upon x minus y equals 1. So of course x minus y equals 1. Step number 5. Solve the equations so obtained. Here also we are one step behind for the final answer. So we can solve the equations x plus y equal to 5 and x minus y equal to 1. So here I am just introducing the next method, substitution method. We can have a brief explanation of that one by explaining each step according to the rules behind that. Rule number 1. Select any one of the equations and express the variables either x or y in terms of the other. Let's have a look for equation number 6. X minus y equal to 1. From that I am expressing x in terms of y. So we are getting x equals 1 plus y. Now what is rule number 2? Substitute the value of x in equation 5. Here please note down the point. I have taken from the equation 6. That means I have to substitute in the very next equation, not in the same one. That has to be noted. So we are getting x plus y equal to 5. That is our equation 5. So I am just replacing x by 1 plus y. So here it comes the linear equation in one variable. 1 plus y equals 5. As you know, x equals 1 plus 5. So here we are getting 2y equals, that means 1 plus y, that means it is 2y equals 5 minus 1. That means I am just transposing 1 plus 2y equals 5. 2y equals 5 minus 1 by transposing. That means we are getting 4. 2y equals 4 means what is the value of y? Y we are getting it as 2. Now rule number 3. Substituting the value of y in equation 7. So we'll get x equals 1 plus y. X equals 1 plus 2 as we got the value of y as 2. So we are getting the value of x as 3. Hence we could say x equal to 3 and y equal to 2 is the required solution. But still I am just confused whether my answer is correct or not. Let's have a verification for that one. Verification. So we can substitute the value of x and y so obtained in our question. 10 upon x plus y plus 2 upon x minus y equals 4. So replace the value of x by 3 and y by 2. We get 10 upon 3 plus 2 plus 2 upon 3 minus 2 equals 4. 3 plus 2 means it's 5. So we are getting 10 upon 5 plus 2 upon 1 equals 4. 10 upon 5 it is 2. So 2 plus 2 we are getting equals 4. That is our right hand side. So hence it is true. Let's go for the second equation too. 15 upon x plus y minus 5 upon x minus y equals negative 2. 15 upon x plus y means it is 3 plus 2 gives 5. So 15 upon 5 minus 5 upon 1 as 3 minus 2 equals 1 equals negative 2. So we get 3 minus 5 equals negative 2. So here we are getting the verification as the left hand side equals the right hand side. Hence the solution for the given system is verified. Now another concept from the chapter, a special type equation. Have a look for the equation. It is of the form ax plus by equals c1, bx plus ay equals c2, where a is not equal to b. What is the specialty of this equation? Have a look for the coefficient of x in the first equation. It is a. And check the second equation. The coefficient of y in the second equation is a itself. So there is a matching in between the coefficient of x in the first one and the coefficient of y in the second equation. Same way, if I am checking, the coefficient of y in the first equation is same as the coefficient of x in the second equation. To solve such equations, the following algorithm may be used. Algorithm. Step 1. Obtain the equations. So ax plus by equals c1 and bx plus ay equals c2, where c1 and c2 are, it can be any real numbers. Add the given equations to get a plus b into x plus a plus b into y equals c1 plus c2. So we can take a plus b as the common out. I am getting a plus b into x plus y equals c1 plus c2. We can transpose a plus b to the right hand side. So we get x plus y equals c1 plus c2 upon a plus b. In order to make it as a simplest manner, we can say x plus y equals c, where c is c1 plus c2 upon a plus b. So we are getting a linear equation over here, x plus y equals c. Let it be equation number 3. Let's go ahead. Step number 2. The first one what we did the addition of the two equations. Now here it comes the role of subtraction. Subtract the given equations to get a minus b into x minus a minus b into y equals c1 minus c2. The same way we are taking a minus b as the common out. So a minus b into x minus y equals c1 minus c2. Then x minus y equals c1 minus c2 on the right hand side, and we are transposing a minus b means it will turn as division. So c1 minus c2 upon a minus b. Here also we are replacing the right hand side by another constant d. Let it be d equals c1 minus c2 upon a minus b. So here we will get the equation as x minus y equals d. So we got two linear equations over here. So step number 4, we will add these two equations to get the value of x. Step number 5, subtract the equation 4 from 3 to get the value of y. Still we are not that much thorough with the concept. Let's have a brief discussion about the concept, the steps that we had a discussion in a detailed way. Example, solve 217x plus 131y equals 913, and the second one 131x plus 217y equals 827. The step number 1, of course, we should add both the equations to get the equation number 3. So we are adding 1 and 2. So we will get 348x plus 348y equals 1740. If we are checking that 1740 also divisible by 348. So we can make it as the simplest form as x plus y equals 5 by dividing throughout by 348. Let it be equation number 3. Now the step number 2. We should go for the subtraction. So subtract equation 2 from equation 1. We get 217x minus 131x. That means we are getting 86x. Go for the next one. 131y minus 217y means it is minus 86y equals 913 minus 827. It's 86. Here also we are dividing by 86 throughout. We'll get the new equation x minus y equals 1. Let it be equation number 4. Step number 4. Add the equation 3 and 4 to get the value of x. So here we are adding both the equations. When we add, we get 2x equals 6 plus y plus minus y means of course it is 0. Then x equals 6 divided by 2. It is equal to 3 by transposing. Step number 5. Subtract the equation number 4 from 3 to get the value of y. So here we are going for the subtraction. So x and x, of course it will get cancelled, and we are getting 2y equals 4. Y equals 4 by 2. We are getting 2. Hence x equal to 3 and y equal to 2 is the required solution. Let's go for the verification. We can substitute the value of x and y in the given equation. So 217x plus 131y equals 913 is our equation. Replace the value of x by 3 and y by 2. If I am multiplying 217 by 3, we are getting 651 plus 131 multiplied by 2. The product is 262. When we add both, we are getting the sum as 930. It's nothing but our right hand side. Go for the second equation. 131 multiplied by 3 plus 217 multiplied by 2 equals 827. Here also we are checking 131 multiplied by 3. What is the product? 393. Go for the next product. 217 multiplied by 2. It gets you 434. When we add both, the sum is 827. Of course, it is our right hand side. So we could say x equal to 3 and y equal to 2 is the required solution. Now it's the time for your assignment. DIY, do it yourself. Question number 1. Solve the following pair of equations by reducing them to a pair of linear equations. In that I have given two separate sections. Question number A. 5 upon x minus y plus 1 upon y minus 2 equals 2. And the second one, 6 upon x minus 1 minus 3 upon y minus 2 equals 1. And the one more question we can do in that one, 3a upon x minus 2b upon y plus 5 equals 0. A upon x plus 3b upon y minus 2 equals 0. And please don't get confused with that a and b. A and b, it is nothing but constant itself. Go for the question number 2. Solve 37x plus 41y equals 70. 41x plus 37y equals 86. One more of the same pattern. 99x plus 101y equals 499. And 101x plus 99y equals 501.